My name is Sudheer Dantuluri. I work as a software engineer in the SMB team here at Microsoft. Along with me, my colleague Thomas will be speaking today on this topic, SMB over QUIC files without VPN. Thomas, you want to do a brief intro for yourself?
Hi, everybody. Great to be here. My name is Thomas Salemy. I'll be joining Sudheer in presenting our work on SMB over QUIC.
Thanks, Thomas. And this is our agenda for today. I'll start by giving a brief overview of QUIC, then get into the details behind the motivation for why we wanted to try SMB over QUIC in the first place. Following that, Thomas will discuss the details on integration and certificate management, and we'll conclude with a discussion on performance and short demo, followed by a Q&A. Okay, we'll start with the overview of QUIC. So QUIC is a new secure networking transport developed on top of UDP. It was proposed and originally started by Google. It was developed by taking some of the best in-class features from other protocols such as TCP, TLS, and HTTP2. So that way it forms the basis for HTTP3. So QUIC allows for faster connection setup, that is 1 round trip time for initial connections and 0 round trip time for resumed connections. So how this happens is QUIC has this concept of a configuration or a session, which is basically an encapsulation of the TLS state, the application layer protocol negotiation, which is a kind of a unique identifier for various application layer protocols that work on top of QUIC, and among other things, stuff such as silos and network compartment. So, and each session or configuration can have 1 or more connections, and each connection can have 1 or more streams. Since the session layer encapsulates the TLS state, once you have established a connection successfully, it caches this TLS state. So later, even if you close the connection and reopen the connection again, or if you want to make additional connections, it can make use of this cached TLS state. So that way it can reduce the additional round trip time. That's how this how you get this 0 RTT for resumed connections. And QUIC offers better security, like it provides mutual auth via TLS 1.3. This means that in addition to server being authenticated on the client can also be authenticated on the server. This QUIC also mitigates man-in-the-middle attacks, as most of the packet is encrypted. So from the word go, QUIC has a secure channel, so you can ensure yourself that your network traffic is totally secure, that you can ensure yourself that the network traffic, the privacy and integrity of your network traffic is never compromised when you are using QUIC as a transport. Some of the improvements that QUIC has over HTTP2 and TCP, as I mentioned earlier, since you have session and each session can have 1 or more connections and each connection can have 1 or more streams, you can distribute your load across multiple streams so that your smaller packets can do not have to get stranded behind a larger packet. This is possible because QUIC has support for multiple streams within a single connection. QUIC offers better transitions between networks. Like once you have a QUIC connection, you can set parameters such as the local address and the remote address of the connection at any time during the lifetime of the connection, and the connection migration or rebinding happens automatically. So this means the connection can easily transition from Wi-Fi to cellular or vice versa. QUIC has also better loss recovery mechanisms, like it supports up to 256 SAT blocks in comparison to TCP's 4, I think. I think TCP has that limitation because of the limitation in its options field size. What this means is that it can repeatedly ACK received packets in multiple ACK frames and the peer will know even if there is a packet loss or maybe reordering, the peer can has a better chance of knowing what packets have made it to the other end. And QUIC also has no retransmission ambiguity. It uses a monotonically increasing packet number. Even if there is a packet loss, every packet is a new packet. And so this allows for a better estimation of the round trip time. Like you, in case of TCP, since you use the same sequence number, when you get an ACK, you're not sure whether you got the ACK for the original packet or for the retransmission. And in case of QUIC, you don't have that because every packet is a new packet. So you make better estimate on the RTT. And QUIC being recently developed, it has the benefit of using some of the latest state-of-the-art congestion control algorithms. And QUIC also allows for better portability and agility, being developed for UDP and user mode. It allows for faster deployments. And then QUIC is also being standardized by IETF. So it gets the benefit of contributions from multiple parties that are interested in the development of the protocol and taking the protocol forward. So a diagrammatic representation of how QUIC optimizes the handshake. In section A, what you see is for the initial connection. And the first one is when you use TLS on top of TCP, and the TLS version is 1.2. And so you have one handshake for TCP and two handshakes for TLS. So there are 3 round trip times before your data transfer can begin. TLS 1.3 optimizes this in the TLS layer. So you have reduction in 1 round trip time. So you get 2 round trip times before you can actually start pushing the data. With QUIC, so it kind of combines these two. You can start putting your data in 1 round trip time. And for subsequent connections, in each of the 3 cases, you reduce 1 round trip time because of the cache TLS state. And that's where in QUIC you get 0 RTT, like you can piggyback your data directly with the hello. That's where in each of the 3 cases you optimize 1 round trip time for subsequent or additional connections. Going into the details of why we wanted to try SMB over QUIC. So with a lot of legacy Windows systems all over the internet, we find that internet service vendors often block port 445, which is what is used by SMB. And the reason being, there are lots of legacy Windows clients all over the internet, and some of them being not very secure. It's only right on their part. So that prevents SMB from being easily used over the internet, even if you take some additional security mechanism in place, like encryption at the SMB layer. So we wanted to solve that problem, and currently, if we have to use SMB over the internet, we need to have VPN for the remote traffic, and there is trouble having to access the cloud providers. So with QUIC, we have some advantages with security. The QUIC connection is always protected by TLS 1.3 encryption, as I mentioned earlier. So even if you're using weaker authentication protocols like NTLM, it is still tunneled inside the QUIC connection, like it is encrypted and signed. So it makes it better, even in spite of being a weaker authentication protocol. And Kerberos is still recommended. That's a default Windows authentication mechanism that's preferred, and so we'll be using KDC proxy by default. Another advantage with using QUIC is it prevents server spoofing. Like when server gets a connection request, it is expected to provide the QUIC layer with a certificate that acts as a proof of its identity. And the QUIC layer passes the certificate to the client side, and on the client side, the QUIC layer, the verification of the certificate is done. Does the certificate present the right name? Does it trust to the is the certificate issued by a certificate authority that is trusted by the client's trusted root chain? And only if all is valid, and there are other additional checks like is the certificate still not expired, or is the certificate not revoked by the CA? All these checks happen on the client side, and only if the certificate passes all these checks will the connection get established. So there are strict checks on the client side on when you're talking to X, we are indeed talking to X. And so how we expect this to work is in cases where SMB port 445 is blocked, TCP 445 is blocked, we expect SMB or QUIC that uses UDP 443 will work. So what this means is enterprises can put their SMB head in the demilitarized zone, and the file services work like it work within the enterprise, even across the internet. And what Google experiments show is that they have a very high success rate when connecting to UDP port 443. And Windows kernel QUIC implementation, it's currently called MS QUIC, allows for multiplexing of multiple services on UDP port 443 using ALPN. What this means is different applications that run on top of QUIC and that run on top of QUIC can share the same UDP port. Like HTTP and SMB both can listen on 443, and the QUIC layer takes care of multiplexing the traffic you get on these ports between these multiple application services that run on the same port, because it can distinguish them based on this additional field called application layer protocol negotiation field, which is a unique identifier for the application that is running on top of QUIC. You have some downsides. Like what we observed is based on our experiments, with Thomas will get into, will zoom in on later, is that we observed poorer performance when even with comparing with TCP with SMB encryption on. Remember, like SMB has its own layer of encryption. Like if you mark a share encrypted or SMB server to use encryption by default, SMB does encryption for all the TCP traffic that it uses. And we don't have good hardware offload support on UDP yet. So that is the current scenario, but this can change in the future. And another thing to notice, like when SMB encryption is on, the session key that is derived to encrypt the traffic that is exchanged between the client and server is based on user to machine. Whereas with TLS, it is the TLS layer that QUIC uses is user agnostic, so it is machine to machine rather than user to machine. With that, I hand it over to Thomas. Thomas, you wanted to start talking about the integration stuff?
Yes. So let's get into how the SMB team at Microsoft integrated QUIC into the protocol. So as we can see in this component diagram, SMB was built from the start to be able to operate with any transport. In fact, one of the most important features of SMB is multi-channel. That in an enterprise, whichever is the most optimal transport, we will switch and use that. And so the way that we viewed integrating QUIC was that we're just going to layer SMB on top of this other transport. So we will go into a workflow later that in detail of how that operates. Next slide. So in particular, though, just a few important things to note. Again, no difference for multi-channel, no change to SMB authentication schemes. But as Sudheer pointed out earlier, SMB with signing and encryption can be turned on. We turn that off by default because we don't want to pay that duplicated cost of having encryption both in SMB and QUIC where it's built in. QUIC multi-session, we happen to not use on the server. And as we said about preventing server spoofing attacks, SMB over QUIC will use a server certificate and validate against that. Next slide. So just going through a workflow and diving in on the component diagram. So a client happens to open a remote share. And so what will happen is that client's going to resolve the server name using DNS. And then this is where the QUIC workflow comes in. So the client's going to fire 2 connection requests in parallel, both TCP and QUIC. Now, TCP is given a bit of a head start to establish a connection. The reason why we do this is that the client doesn't know if the server supports QUIC at all. This is a new part of the internet. For all we know, it could only support TCP. It might even only support QUIC. We allow the configurability of both of that. So we fire 2 parallel connection attempts to see whichever channel connects first. And based on whichever channel connects first, we will go and use that as our transport. Now, after this, SMB's stack kicks in and multi-channel is going to query the interfaces from the server, is going to select whichever is the most optimal protocol. So say that your network has RDMA capability. We will actually then, after this, go and transfer probably into RDMA as your transport. But yeah, after this, the client is just going to go through the normal SMB flows, send messages. On the server side, we are going to start by opening endpoints that listen on port 443 for UDP. And then when the server receives new connection requests, we are going to assume at this point, not getting into certificate management just yet, that you set out your certificates correctly. And upon that, we will go and try to find a certificate, particularly for this QUIC connection. Given that it does find a certificate, we will accept the connection, TLS will pass, and again, we'll start receiving the QUIC streams and processing your SMB messages. So a big part of the story that either developers or admins have to now manage is certificates. So we built out a bunch of commandlets to help with that. Next slide. So yeah, going actually back into the part where SMB Server creates a listening QUIC socket, we don't register any certificates right by default. And so if no certificates are registered, any connection attempt is going to fail at the TLS level. So the user has to associate a certificate with any of the multiple SPNs that the server supports using our new PowerShell commandlets. And the certificate will then be installed into the local machine store, registered with QUIC, and from this point on, connections using QUIC to that SPN will pass TLS and properly function. So on SMB Server, we see those 3 PowerShell commandlets are how we manage certificates that happen to be then registered. And so new SMB server certificate mapping, which creates your mapping and then remove and get. And a great part about the get SMB server certificate mapping is we actually include a status so that if the underlying certificate, if at some point during the life cycle of your file share happens to be corrupted, or say that for some reason somebody removed it, we'll actually show the status in here to show you whether or not that certificate was loaded properly. And then new features on top of get SMB Server configuration. Enable SMB QUIC is going to be on by default. You can turn that off if you don't want to have listeners be started and be able to receive connections. Disable SMB encryption on secure connection. This is also enabled by default. And again, this goes back to the idea we don't want to duplicate the work of encryption when this is built into QUIC. This is why QUIC is great. And then restrict name pipe access via QUIC. And then a new part of get SMB multi-channel connection is that now that we support 3 different transports, TCP, RDMA, and now QUIC, if you want to debug or you want to see the transports that are being used with SMB connections, you can now do that, and we'll print out your connection counts for that. Next slide. So on the client, you can now specify the transport type. So if we want to use QUIC and only QUIC, rather than, again, firing off those 2 parallel connections for both TCP and QUIC and maybe not knowing which one is actually going to be used, we can specify the transport type either with new SMB mapping or net use, whichever command you happen to use. And then if we want to skip the certificate check, we don't want to validate the server certificate on the client, we can also do that. We don't recommend this, especially for internet-facing services, but there is a case within the enterprise where we know the communication channel is secure and that certificate check might not be needed. Yeah, then pretty similar to on the server side, right? We have the get SMB multi-channel connection. We have get SMB client configuration where we can actually force SMB encryption over QUIC if we want. So override that default setting of actually duplicating for some reason if we want the SMB encryption stack. And then, yeah, skip certificate check. And get SMB mapping now shows the different transport types that are used alongside the mapping. And then one comment before we get into performance on certificate usage that we want to point out and recommend is that we recommend people avoid self-signed certificates and always use certificates from a trusted root authority. So we understand why QUIC is so important, right? We're helping expand SMB into the open terrain of the internet, removing the need to set up complex VPNs for edge file access. We have results from public data how it decreases latency in environments of low network connectivity. So here briefly talked around some of the Google data points, especially in India. But we have yet to see how QUIC will perform within SMB and the enterprise, which has high performance topologies. So the job to be done here, the purpose of our benchmarks, is to know if QUIC performs well enough to the current state of the art. And the current state of the art is SMB encryption over TCP. So really quick, I want to note that when running workloads during a benchmark, really critical to negate any potential bottlenecks from non-correlated dependencies. In our case, we removed the dependency to disk. And we did that by virtualizing the storage stack with an internal tool called RAM disk, so that whenever it receives an IO, it pretty much just doesn't process it. Without doing this, likely would not be able to see the difference between TCP and QUIC and see how they scaled differently. Next slide. So we are left with the following graph, which shows kilobytes per second versus message size for TCP and QUIC. So the reason why we plot message size on the x-axis is as we increase the size of the message buffer, there's going to be a larger buffer to decrypt and encrypt, with the bulk of the work lays now with encryption. And so we're going to increase the amount of CPU required. And so in this workload, we have 2 clients, 25 gigabit per second NICs and read-only workload. So we can see that QUIC matches the performance of TCP with encryption. That's only when a single core is required at 4 kilobyte message size, or almost reaches it. But TCP with encryption scales far better than QUIC as more cores are saturated at 256 kilobytes, by example. And we're going to talk about briefly why that is, and why it's actually not too surprising, because we know whenever a new technology in its immature stage is being developed, it's probably going to be inferior to its former predecessor. But we'll be quickly adjusting this so that we can match the performance of TCP. Next slide. So if we actually go in and look at the flame graph of both TCP and QUIC during these workloads, we can see that TCP is leveraging multiple cores across to handle both of the clients. And this is really important. It's that SMB has spread the compute of the encryption task across multiple cores really well. And so when you have a machine that has, say, 8 cores, 16, 4 cores, you can use all of those cores and you are going to scale really well. So if we now move to QUIC, what we see is that for 2 connections, the actual work, the thread that handles the encryption and decryption, that happens on a single core and only a single core. It gets pinned to a single core. And as a consequence, we can't spread compute and use all of the resources that we have at our disposal in the hardware. And so again, this is just a part of QUIC in its immature stage. And that's the reason why we see the gap in performance and scaling, is that we're not using our hardware as well as TCP does inside the QUIC stack. So yeah, that is the SMB QUIC versus TCP performance comparison.
So I'll play a short demo. Thanks, Thomas, for the detailed discussion. So here we're trying to connect to an SMB share on Azure over TCP first, and we show that we aren't able to do it successfully. And when we switch to QUIC, we actually will be able to talk to the share. So he's trying to connect to the share on Azure via TCP. See, yes, it cannot successfully establish. Not a great user feedback there. And now we try over QUIC. So like SMB or TCP uses 445 and QUIC uses 443. So we have Wireshark capture telling us if the traffic is actually happening over 443. You see that you successfully be able to connect to the share and view files on that share. And by Wireshark, you see it's protocol 443, and it's showing that we are talking over QUIC. All this traffic is encrypted. So because this is encrypted within QUIC, it doesn't know whether it is SMB2 or not. I think with that, we are done. We can take questions. What status of support QUIC in Samba? We don't know the answer to that question, I think.
Yeah, so Samba is supported by who's it? Stephen French, who I think is actually presenting after this talk, and I would direct questions to him because he deals with SMB implementation. For Linux.
Yeah, Linux, yes. He's a subject matter expert in that area. I think we have a talk, just like Thomas stated, after this. Is the quick transport on Azure files already available publicly for testing? Not yet. And we don't know the real timelines regarding that. If you have any questions related to the release details on when this is going to be publicly available, you'll probably have to reach out to Ned Pyle at Microsoft.com. He is our program manager for this feature, and he'll be able to give more details on that. The QUIC implementation that Microsoft uses is MS QUIC. It's an open source. It's also developed for Linux as well as Windows, though for Linux we don't have the kernel version. I think only for the Windows we have the kernel version. And Nick Banks is our expert on the QUIC side. If you have any questions, he'll be able to. Yeah, someone pasted the link of the GitHub link for MS QUIC. You'll find a lot more details related to the QUIC implementation there.
How do you decrypt this if you need to look into the SMB traffic for debugging? This is a great question. So in fact, one of the, at least the way that I do it is that I dump SMB traffic before it goes into, before it actually gets encrypted by QUIC. But so here, I don't know if you can point more towards.
Yeah, in the demo version, we used a workshop version that is kind of a slightly older version. So it doesn't show the underlying SMB traffic within QUIC, but the later versions of Wireshark have support for it. So you'll be able to see the actual SMB traffic underneath the QUIC traffic with the later versions of Wireshark support, which has that support of kind of being able to unencrypt the QUIC traffic and see the SMB packets in there. So I think the Wireshark development version, latest Wireshark development versions, you'll be able to see that.